between what, 19 and 22. Let's see.
Okay, so
How about number
yes,
20?
yes. Don't forget, all solutions are posted.
Mhm.
But I want to go over problems anyway, so we can select any problems you want. Yes, you said number?
Yeah, we'll do number 20.
Okay, so in number 20, we are given a1 equals 4, an equals 3 multiplied by an minus 1 plus 3, and this is for n greater than or equal to 2. We're asked to find the first 4 terms of the sequence. So here's what I do first. I look, and I see a7 equals 3 times a6 plus 3. Okay. A10 is 3 times
9.
9.
exactly. So now I know what's happening here. Every term of the sequence is obtained by multiplying 3 by the previous term of the sequence and adding 3 to it. So now I can determine any term you want. But I am asked for the first 4. So A1, A2, A3, A4. So how much is A1?
4.
That's it. It's given to us. How much is A2? Dictate what we should write.
3.
Multiplied by 4 plus. Is this okay, Harry? Is it clear?
No, like I said, I just sat down and I forgot how to do the whole thing.
Okay. So 3
No,
times
this is
4.
easy.
Okay. 3 times 4 is 12 plus 3 is 15. A3. Let Harry say something.
All right.
What will you say?
So if we're doing that, it would be. Now we're going down with the numbers, so it'd be 4, 3, 2. 2 times, or no.
So
it'd be
this
3
is
times,
this is the pattern.
Okay, 3 times. So we're starting with 15 is the next number. It equals 15. So 3 times.
So if this number is 3,
Mhm.
then this is 3 minus 1, which is A2.
Which that would
So
be
I
15
copy
if we got it.
3. I copy the previous term that I just determined, and then plus 3.
Okay.
So this is 45 plus 3, 48. Let's try A4,
Okay, then you take the 3 times.
because that's the 3 here.
48, which is
Exactly.
the end
And
number,
then plus 3.
plus 3.
And that's 147.
Okay.
So when you're given a recursive formula, try to understand the pattern, try to understand what it's given to us and what we're asked to find. And just follow the pattern.
For this one, do we add them all up? Oh, no.
A1 to A2 to A3 to A4.
27.
So what do you mean by 27?
Number 27.
Oh, number 27. From that form.
Yes.
Okay, number
Oh,
20.
okay.
Solution
Okay.
notation.
They are the exact same problems, but I crossed out few from, because I can't make any changes. When I print out from my MATLAB, I can't make any changes. Okay, I see what it is. So we have 1 plus 3 plus 5 plus dot, 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 plus 2n minus 1. And we're asked to change it into, or condense it using the sigma or the summation notation. I have to have I equals something. I have to end with something. And I have to have an expression that I apply it to. The expression has to have I.
I plus 1.
Okay. To what?
2 and minus 1.
N.
To n, very good. And then what is the expression? To I? Perfect. Let's check. Let's check how we get the first term, how we get the second term, and so on and so forth. If I is 1, 2 times 1 minus 1 is the first term. If I is 2 now, 2 times 2 minus 1 is 4 minus 1. I got the second term. When I is 3, 2 times 3 is 6, minus 1 is 5. And I finally get to n. When I is n, 2 times n minus 1. Is that okay? Okay,
The last one, 2 times n.
minus 1.
Oh,
That's the sequences, right?
yeah.
Yes,
Okay.
good. Next question.
Can you do 19?
Yes, 19. In 19, we have, what do we have in 19? Okay, so we have an. This time, the general term or the nth term is given. -1 to n plus 1 divided by 3 to the n minus 1. And we are asked a1, a2, a3, a4. This time, it's easier. Why? I don't have to look at a pattern. I only have to plug it in. Okay, so let's plug it in. N equals 1. -1 to 1 plus 1, which is 2, over 3 to the first power minus 1. -1 squared is 1. 3 minus 2 minus 1 is 2. Done. Now I need to find a2, which is -1 raised to 2 plus 1, which is 3, divided by 3 squared minus 1. 3 squared minus 1. -1 to the third is -1. 3 squared is 9. 9 minus 1 is 8. The answer is -1 over 8. Is this okay? Any questions? Which part is not clear?
The 3 squared.
9. 9 minus 1 is
Well,
8.
how does it get it to 2? I guess that's where I.
2. N is 2.
So whatever number
so
in the
we-
sequence.
2 plus
Okay.
1 is 3.
Okay, I was doing it the opposite
3
way.
squared minus 1. 9 minus 1, 8.
Okay, I was thinking we had to use the half, and that's where I got confused on that.
No, this is not a recursive
Yeah,
formula.
Okay,
This does not depend on a n minus 1
okay, that's
or
what I was-
a n minus 2.
Yeah.
This is given to us straightforwardly,
this part,
not
okay.
like this. It depends on
Yeah.
something else. Here is the general term or the nth term. Plug it in.
Okay, that works, thank you.
Okay, so do we have to do the other two?
No, that makes sense, yeah.
Everything okay?
Yeah.
Okay,
As long as it's-
So you're just substituting if you're on A1, 2, 3, 4, that 1, 2, 3, or 4 is
Exactly.
the N term.
exactly.
And then figure it out.
Because n means, so a1, comma, a2, comma, a2, a3, dot, 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 an. If I have this, how do I get the first term? Replacing n by 1.
Yeah.
If I have this, how do I get the second term? Replacing n by 2.
Okay.
And so on and so forth. Is that clear?
Mhm.
Okay.
Yes.
So these are the topic for test for the final exam, and I'll talk about it in a minute. What am I doing next? 16. Well, I can find 16. So what does it say?
It's a system of inequalities.
Good?
Okay.
Is that 16?
So break it up.
It's,
X plus Y plus
Negative 11? Okay.
and X minus 2 squared plus Y plus 6 squared plus X is 4.
that's not as good.
It's x minus,
2.
that's okay. So let me read it back to you one more time. X plus y equals negative 11, correct?
Mhm.
X minus 3, everything squared, plus y plus 6 squared equals 34.
Mhm.
Okay, very good. Obviously, this is a system of equations, and I don't have the same variables in the top equation and the bottom equation, so I have no choice but to use what? Substitution indeed. Very good. It doesn't matter which one you want to substitute, but tell me what you started doing. If you want, we can substitute for x or y because both of them have coefficient 1. It doesn't matter which one you want to substitute.
The one.
No, x or y. Do I solve this equation for x or for y?
No, let's solve for x.
Okay, let's solve for x. So this is negative y minus 11. So far, so good? Now, in here, this will become negative y minus 11. So far, so good? Okay, forgive me, add up your points. Make sure I didn't make a mistake or anything like that because I already had to correct one test. Okay, so always do that. So, I'm sorry. See what I did? We are replacing x by negative y minus 11, not the y. So this has to stay. See if I'm all over the place. Okay, sorry about that. So negative y minus 11 minus 3, everything squared, plus y plus 6, everything squared equals 34. So far, so good? Perfect. So then I have negative y minus 14, everything squared, plus y plus 6, everything squared equals 34. When I expand this, how many terms do I get?
No, 2, sorry.
For 13 weeks. We have an agreement. For 13 weeks.
And this is
That's true. We are all tired. We are all tired, I understand. So how many terms? 3 terms. Very good. The first term squared. Minus 2 times the first times the second. Plus the second term squared. Why do I know it's all positive? Because I can factor out negative 1. It's y plus 14. And when you square negative 1, it's positive. Right? So all this, because both terms are negative, everything will be positive. So the first term squared plus 2 times the first times the second, plus the second term squared. So how much is 14 squared? Oops. So it's 196?
sounds right.
Okay, thank you. 196 plus the first term squared plus, very good, plus 36. Okay, so I think we are awake now. Yes, good, good. Okay, so then I have y plus squared plus y squared, 2y squared. Here I have plus 40y. So I move this because it's quadratic. So 36 minus 34 is 2, plus 196 is 198. I'm hoping that in this class you learned 3 concepts, very important. Factor, simplify, and clean it up.
So
What will I do? What do you think I'm going to do next?
we can divide it by 2.
Of course. So then this is y squared plus 20y plus 99. So I think so. Right. Now, if it takes more than a blink to factor, especially in a test situation, I'm not going to waste my time. I'm going to go ahead and negative b plus or minus b squared minus 4ac over 2a. And put in the graphing calculator. And I think I have my calculator somewhere, but I'll put it in here. Okay, so parentheses for the top, negative 20 plus the square root for, oh no, that's not what I meant. Square root, parentheses, 400 minus 4 times 99, close the parenthesis, close the outside parenthesis, and divide by 2. Negative 9. And then I copy the entry and change the positive in front with it to it. Of course, if you see how to factor in a blink, otherwise I'm not going to waste my time. If you have any difficulties with factoring, do just this. So -9 and -11. So I got that x equals -9 and x equals -11. Now I do have to go back. Okay, keep an eye on what I'm writing and what I'm doing, please. Okay, so -9 minus -9 with minus in front is 9. 9 minus 11, x is -2. And with -11 plus minus 11 is 0. So the two options are -2 comma -9 and 0 comma -11. Is this okay? Good. Next question, next problem, next topic, anything you want. Yes, please.
Can we do
Yes.
number 8?
Yes. Number 8. If I find it, yes, I did find it. So this is log base 4 from the 7th root of a to the 6th, b minus 1 to the 3rd over 16. Okay? There are only 3 properties that we can apply here, right? Log applied to a product, which is the sum of logs. Log applied to a ratio, which is the difference of logs. And log applied to a power, which allows us to bring the power in front as a factor. The power rule. Okay, perfect. So the first thing I have to do is eliminate this. What power is the 7th root? Don't say 7.
Is that 100%?
Yeah, no, I'm kidding, I'm kidding.
We got 1 point for that.
Log base 4 of a to the 6th, because it's very easy to make this mistake and say power 7, but we understand this, the 7th root is not power 7. Good, perfect. Okay, so now I leave 1/7 outside, and if you remember, I think it's easier to remember this, but I don't want you to memorize stuff, right? So when I apply log to a ratio, the quantities that are at the top will have plus in front of log. The quantity that is coming from the denominator will have minus in front. And then I can do it straightforwardly in one row. If you don't want to do this, tell me and I'll do it in a different way. So log base 4 of a to the 6th plus log base 4 of b minus 1 to the 3rd, but minus log base 4 of 16. You don't have to do it in one step, but why waste the time? If the quantity is at the top, we will have positive in front. If the quantity is in the denominator, we'll have negative in front, and that's it. Now it's not done because of this power that will go in front like we did with 1/7. So this power will go in front, this power will go in front, and now we are trying to figure out what this is. So let's give it a shot. Log base 4 of 16 is a number that we don't know what it is. But remember, the most important concept in chapter 4 is to be able to change a log equation to an exponential and an exponential back into a log. So let's change this into an exponential, and that's very important to remember how to do it. How do I do this? 4 to whatever equals 16. What can whatever be? 2. 4 squared is 16. So this number will be replaced by 2. So here's final step. Bring 6 and distribute 1/7. 6/7 log base 4 of a plus. Bring 3, distribute 1/7. 3/7 log base 4 in parentheses b minus 1 and minus 2 multiplied by 1/7. Correct. Very good. Again, you didn't have to do these in one step as we did it here. Change it from log applied to a ratio and product. Good. Anything else from test 3? Or I know I repeat myself all the time. Solutions for all tests are there. I will print them out. Do not look at the solutions. Solve all those tests 10 times and then branch off from there doing more problems. Which problems? I saw that. Just give me 1 second to finish up my. Vinci, I still have that portion of your test. You left it here. Thank you. Okay, so after I would redo all tests as many times as I can. I have the time to go through all problems and make sure that I understand everything and I'm able to reproduce everything. Then I will go through these. Yes, I'm ready. Sorry. Forgive me. Chelsea.
Number 9.
Number 9. Okay, I don't want you to waste. I don't want us to waste time. So what was? Oh, I think I got it. Okay, so it's 3 log 2x plus 1 minus 4 log x, not 4, log x. Good. So this is exactly what we did. The number in front goes back now. So this is log 2x plus 1 cubed minus log x to the 4th. So the numbers in front go back where they came from, and they came from the power of those quantities. And since it's a difference of 2 logs, how do I replace this?
Irrational.
It's log applied to a ratio. It's not a ratio of logs. Be very careful because it's very easy to make that mistake. You cannot say log of this over log of that. So this is log of 2x plus 1 to the 3rd over x to the 4th.
Excuse me,
Yes,
I don't have this question on my mind.
yes you do. Yes you do.
Not the other one.
It's not the same number.
It's number 10 on the yellow one. Oh,
It's not the same number. I copied everything after I wrote the test and my math lab said 41 minutes. I said 41 minutes, it's not bad. And then I copied it in by hand,
Is the final gonna be just one test?
just one test.
Okay.
I may have 2 versions of the test,
Yeah,
but
it
the
won't
same.
be math
Yeah.
lab for you.
No,
Okay.
it takes me 3 hours to copy what they have in there. Yeah, because then I go back and I write solutions and then I exclude things and I print it out and then I cannot make any changes.
Yeah.
I can only cross it out after I print it out and
Mhm.
Let's do some,
yes, which one? 7? Okay, very good. Let's look at 7. Where is 7? If you have it, okay, yes. So the percentage of adult height attained by girls who are X years old can be modeled by the function f of x equals 62 plus 35 log of x minus 4. Okay, where x represents the girl's age. X is the age. So that's one thing that I observed and I wanted to refresh your memory on. Every time you read a problem, take some notes and look at it. Oh, okay, so this is the function and x is age. Okay, then I read on. X represents a girl's age between, okay, f of x represents the percentage of her adult height. Percentage of her adult height. So I see it right here in front of me. It's a paragraph. Where will I find it? Maybe I can see it or not. I use this function to determine approximately what percentage of her adult height girls are at age 14. Once I have this in front of me, I should not make a mistake. Because I think it's clear what I have to do. What would you recommend? Anyone? That's it. That's it. 62 plus 35 log x minus 4. When you put everything in the calculator, you get 97%.
what's in the next one?
Because 14 minus 4 is 10, log 10 is 1, and all you have to do is 62 plus 35. That's it. Good. Next question.
We
Five.
do number,
Which one?
I was gonna say 12.
Number 12.
Yeah,
Number 12. Okay, this is a log equation. So we have log base 2 of x plus 6 plus log base 2 of x plus 5 equals 1. Okay, first I'm looking at the equation and I would ask myself, what is it? What type is it? Because I know so many. I know linear, I know quadratic, I know rational, I know, yes.
Don't you have to find the domain first?
Yes, but first, that's why, perfect, awesome.
I'm just so mad at myself because when you wrote it up here, I know exactly what to do, but on the test, I did not. know
Yes,
this.
that's why I recommend on scratch paper, take notes. Maybe you want to rewrite it and see it in your own handwriting, in your own writing. It's because when I see it here and I see it here, it may be different. Yeah. So first I have to ask myself, and you're on the right track, but you're way ahead of me. My first question to myself is, what is it? Because I know so many. I know exponential, I know logarithmic, I know radical, I know linear, I know quadratic, I know polynomial, I know rational, absolute value. I have so many different equations. Oh, it's log. Okay. Then I ask myself, oh, wait a second. Log is not a friendly function. If I don't state the common domain, then I have to go back at the end and check which one I want to do. Which one we want to do? Do we want to check at the end and not find the common domain, or we want to find the common domain? I know some of my flaws. One of them is I may forget to go back and check. So for me, it's easier to state the common domain. But you can say, no, that's too much work, but I will keep in mind to go back and check, whichever you prefer. It doesn't matter to me which one. But if you don't go back and check and you choose the wrong answer, or you can include the wrong answer in the solution, then you will not get full credit. So let's choose one or the other. Number one, we state the common domain. So then we know that if the solution is not in the common domain, it's not a solution. Or we say, this is a function with problems. I have to remember to check at the end. Which one? We have to choose one. We want to check. Okay, so I'm writing myself a note. Do not forget to check. I may still forget, right? It's possible because it's an anxiety for the test or the final exam. So I may still forget, but I wrote myself a note. Hopefully I will not forget. Okay, good. So then I will have to condense this. I'm not finding the common domain. I will condense it directly. What is it?
That's log base 2, x plus 6.
Multiplied by x plus 5 equals 1. Awesome. Because it's a sum of logs, it gets changed into log applied to a product. If it's log applied to a product, it will be the sum of logs. Awesome. Good. Now I am ready to convert it. How do I convert it? 2 exactly equals this. I just want to multiply it. It's x squared plus 5x plus 6x is plus 11x and plus 30. So I didn't want to write it one more time. I was lazy. I'm already multiplied. Now I'm asking myself another question. What is this? So that I know how to address the issue or to solve it. What is it? Say it again. Quadratic. So I have to set it equal to 0, obviously. So x squared plus 11x plus 28 equals 0 by subtracting 2 from both sides. So now I'll say, if it takes a blink to factor, I'll factor, because no one can force me to use a particular method now. I'll do whatever I want. So if it takes this much to factor, I'll factor. If it doesn't, quadratic formula.
7 plus
So then two options are given here.
-7.
And I will say not so fast. Because I have to do what? Yes. Yes. Okay. I'm going back with -7 in the original problem. -7 plus 6. Is that okay?
That's -1.
Correct. So can I apply log base 2 to -1? No. Very good. This is out. So I'm going to check -4. -4 plus 6. That's okay. -4 plus 5. That's okay. So this is the only one. Does it make sense? Okay. What else? Anything else from this test? Anything else?
5.
5 you said. Okay, sorry, I didn't hear. 5. Okay, so again, this is a word problem. I'm copying both functions, 6.19 times 1.029 raised to power x, and then g of x, 37.3 over 1 plus 6.1 e to negative 0.052x. I read the problem and I take notes. The bar graph shows the percentage of people 25 years of age and older who were college graduates in a certain state for 7 selected years. The functions below model the percentage of college graduates among people ages 25 and older, f of x, and x is number of years after 1950. Which function, f or g, is a better model for the percentage of people ages 25 and older who were college graduates in percentage of them who were college graduates of 25 or older in 1980? And the bar graph in 1980, shows 17.0%. So this is from the graph. So I'm given two functions. They represent the percentage of adults 25 years and older who were college graduates in different years. X is the number of years after 1950. I am asked to find the percentage of 25 and older who were college graduates in 1980. And from the graph, I'm given this. So what do I do? Very good. So I have to find f of 30, and I have to find g of 30. Whichever of these two is closer to 17%, I would say that's the best model for 1980. I cannot conclude that is the best model for all years, but I will conclude that is better for 1980. So let's go to y equals. Let's carefully put in both functions. 6.19 in parentheses, 1.029. Close the parenthesis, caret. You know me, I put parentheses everywhere. Okay. Now here's the second function. Parentheses around the top, 37.3. Close the parenthesis, divide by, parentheses for the denominator. 1 plus 6.1 e to parentheses, negative 0.052. X, close the parenthesis for the power, come down, close the parenthesis for the denominator. And go to second table. And what am I plugging in? Oh, of course. Hold on, let me see. Oh, that's okay. So what am I plugging in? The first one gives us 14.593. The second one gives us 16.347. Which of these two models is better? I'm not saying is the model. I'm saying it's better to approximate 17%. Indeed, this. G of x is roughly 16.347%, and this is 14.593%. I'll say better for 1980. I cannot conclude about all the rest. I can only conclude for 1980. Good. Next question, please. Are you going to be okay with the other two tests? Are you? Yes, please. Yes. Yes. So in number 4, we have an exponential function, which is f of x, 542 multiplied by 1.026 raised to the x power. Models the population of a country f of x in millions. Millions. Population. X years after 1970. X is the number since or after 1970. Okay. Answer the following questions. Find the country's population in 1970, 1997, in 2024, and in 2051. So I have to find f of 1970, which is the number of years since 1970, which is f of 0. The other one for 1997, I plug in 7. For 2024, I plug in 2024 minus 1970. What is that? 14? Oh, I'm sorry. Yes, of course. Oh, I made a mistake here. That's why. 27. Sorry about that. Indeed, 54. And then 90. What is it? 20. Thank you very much. Thank you. Of course, I cannot do this with a calculator. By hand, I need the calculator, I meant to say. Natalie is right. It's the end of the semester. We are all tired. We don't, so keep an eye on what I'm saying. Okay. So in parentheses, 1.026 caret parentheses x, close the parenthesis, go to second and table, and I plug in 0. I plug in 27. I plug in 54, and you gave me 81. All I have to do is copy these numbers. So after I copy these numbers, the question is also asking us what happens to be happening. What appears to be happening to the population of this country every 27 years. Exactly. It doubles. It appears to be doubling from 542 to 1083, and then again times 2, 2167 roughly, and then times 2, 4300. Any questions? Yes, please.
Are your speakers sitting too close to each other? Do you hear that?
Oh, yeah.
Is it just me?
I thought it was
driving
me.
me crazy.
Is it this you mean?
Yeah, I think they're like sitting too close together. Do you hear it up there?
No.
Oh my gosh. So
I just assumed it was me.
Yes, so did I. I don't hear it now.
What does this do with this?
I can hear
There
it
it
now.
is.
It's only because they're on, but there's nothing like. Yeah, it's so weird.
Done.
Oh, I still hear it.
It's weird.
You still hear it?
Yeah.
How come?
Do you hear it? No?
No. I'm still clogged up from the illness.
I don't know what it would be then. I just saw his fingers.
Or do you hear it now?
Then it's not.
It like goes on and it goes away. I still hear it though. I don't know what it would be. Maybe it's from the.
I can't hear anything.
I think it's just.
Yeah, you just don't really tell.
But I unplugged everything.
Yeah, it's such a high pitched noise, it's just coming from something.
I don't think it's
Where-
right. It's not. from
What about
there.
now?
It could come
I
like
still
that.
hear it.
It's like it's coming from all here.
I also hear my right ear.
Yeah, it's over this way.
What about now?
Yeah.
Oh, yeah, it's still there.
It has to be like a light or something. I'm thinking.
Yeah, but it's weird because it went away that one
It
time.
can only go away
Might
and
be
then
one
it'll
of the
come
lights
back.
coming.
I'm so sorry.
It's
I mean, I unplugged everything.
I don't
There
think
is not even power here.
it's not from that place, man. I
Yeah, it
think
might be a
it's-
light or one of the
maybe
wall
it's from
speakers.
the building, maybe it's just somewhere
Building.
here.
Oh, yeah, I hear it.
It's still there. No, it's definitely there.
No, it's not. Did you just hit something up there?
I turned off the volume on this.
Yeah, I don't hear it now, so.
Oh, there it is.
There it is. Yep,
Hey,
that's getting louder.
And I'm not saying anything.
Oh, is it your microphone that you use?
No, I don't, I'm using this, but this is just recording. It's not
Yeah.
transmitting.
Well, whenever you turn that thing back on the desk, it's like you back on.
Maybe we are being recorded.
Probably are.
Yeah, now I
Okay,
don't
now,
hear it.
okay, so there it is. I'll just leave everything. That's good, it's gone. Leave it.
Yeah.
Is it better now?
Yeah.
Oh, yeah, it's completely gone.
Oh, awesome, awesome, awesome. I probably did something, I don't know. Okay, yes, next question. Yes,
21.
so we are only focusing on one test
I could be wrong.
the entire time? Okay, 21. In 21, we have n plus 1 factorial divided by n factorial. Which one is bigger?
The top.
Yes, so you can write n plus 1 times n factorial over n factorial and simplify. So it's n plus 1. We did something similar in class. Yes, next question. Is there anything else from this test? Anything else from this test? Okay, so let's look at other topics then. So back to,
I have the questions.
yes, please, anything.
This is the first one.
Yes, whatever you want.
X squared minus 6x equals -2.
And what are we asked to do?
Solve the quadratic equation by completing the square.
Okay, very good. So -6 is the middle coefficient. I divide it by 2, I get -3. I have to square -3 and I get 9. That's the method, and I have to add 9 to both sides. So the left-hand side is this. Can anyone tell us how to condense it?
X squared minus 6x equals x minus
To write
3
it out,
squared.
Second.
X minus 3 squared.
Very good. Yes, Vinci, what do you,
How did you divide?
the middle coefficient divided by 2, square what I get, and I get 9. So then this is 7. What now?
Square root, so
Indeed. How many solutions do you expect?
2
Very good. So you will not forget what?
plus
Exactly. X minus 3 equals plus or minus the square root of 7, and we are adding 3. Good, very good. Good example. This is from here. This is from equations. Very good. So we looked at word problems. We looked at exponential equations, log equations. We did not do another example like this. You didn't say anything. Systems of nonlinear inequalities we did not do. And we looked at sequences. And we looked at equations. Bless you. What about the piecewise defined function? What about the difference quotient? What about the circle?
piecewise.
Piecewise. Yes, please.
Okay. Then we do the function composition.
Yes. So because she picked up a piecewise first, and then don't forget. I may forget. Okay. A piecewise. Good. Here it is. X squared minus 1 for x less than or equal to 2. Negative x plus 2 for x greater than 2. This is a piecewise defined function. So what is the starting point? We're asked to graph it. So whenever we're asked to graph a function, what do we have to do